Hello, welcome to a new unit on complex numbers. In this unit, we are simply going to go over the different ways to express a complex number. The requirements would simply be to know the formulas for a binomial, Cartesian, trigonometric, and polar form of a complex number. Suppose we have the complex number 1/2 minus root of 3 divided by 2i. We want to calculate this complex number in Cartesian, trigonometric, and polar form. Let's first calculate the modulus and argument of this complex number. Remember, the modulus is square root of the real part squared plus the imaginary part squared. That is, in this case it would be a half squared plus root of 3 divided by 2 squared. Notice that here the sign of the imaginary part does not affect anything because it is squared. Therefore, it would be equal to the square root of 1/4 plus 3/4, or what is the same as the square root of 1, which is 1. Therefore, the modulus would simply be 1. The argument, if we apply the formula we have seen so far, would be the arctangent of the imaginary part divided by the real part. The imaginary part is minus root of 3 divided by 2, the real part a half. If we fix that fraction, we have that it would be minus 2 root of 3 divided by 2 times 2 times 1. The 2 can be simplified, and we are simply left with the arctangent of minus root of 3, which is 5π3. Notice that this complex number already appeared in a previous unit, and we knew what its argument was. Well, with these two data, we can already pass from the binomial form to any of the other remaining forms. The Cartesian form would simply be to write the real part comma, the imaginary part simply. The trigonometric form is also very simple. It would be to write the modulus, which is 1 times the cosine of the argument, which is 5π3 plus I, times the sine of 5π3. Then the polar form, which is simply a more abbreviated form than the trigonometric form, consists of writing the modulus, which is 1, and as a subscript, the argument, which in this case is 5π3. Graphically, we have that this complex number is in the 4th quadrant, as we can see. Well, let's see a second example. Now let's try to go from a polar form to a Cartesian, trigonometric, and binomial form. In this case, it is much simpler. Notice that in polar form, we are given the modulus, which is the root of 2, and the argument, which would be 3π4, simply observing the form of the polar number. Then it would simply be a matter of expressing the trigonometric form consisting of the modulus times the cosine of the argument 3π4 plus I times the sine of the argument, which is 3π4. The binomial form simply consists of simplifying this trigonometric form. If we look at the cosine of 3π4 is minus the root of 2 divided by 2, and the sine of 3π4 is the root of 2 divided by 2. Now, if we multiply root of 2 times minus root of 2 divided by 2 and root of 2 divided by 2, the square roots will be simplified and we will have minus 2 halves plus I times 2 divided by 2, or in other words, minus 1 plus I. Well, and once the binomial form is obtained, the Cartesian form is immediate. It is simply a matter of writing the real part and the imaginary part together in a vector. Graphically, this complex number would be in the 2nd quadrant, and as you can see, would simply be minus 1 plus I. Well, so much for today's unit. Hopefully you have been able to review the different expressions of a complex number. See you in the next unit. Thank you.